All right, so once you've got in your Splunk and you've answered the first few questions, then you can start seeing the defacement file name, and you do this by finding traffic that goes backwards. So here, I've just searched for stream equals source type equals stream HTTP, and I'm really not Batman.com. So I'm seeing traffic to the web server. Okay, let me close those windows again. All right. That's quieter. All right. So now what I want to do is find traffic that went backwards through the network. Notice right here, the client IP has a couple addresses. These are people sending data to my web server and the source of that data. Now, these Accunetic scans went to my web server. So here's one, an Accunetic scan going to my web server, and the source of that is the attacker's IP, but I want the destination of that, which is this. I just want to put that in a clipboard. That address, ending in 70, is the address of the web server. So if I go up here and click a client IP, and just click any one of these values, that will fill it in the query for me at the right format. And now I can replace that value with the IP address of the web server. And the point is, I'm looking for HTTP requests coming from the web server. This should never happen. Your server should be a server and not a client. If you install Windows Server software, it will limit the browser and not let you download things. You're not supposed to be on a server, opening a website and downloading stuff directly to the server. There's two reasons for that. One is that you might get the server infected, and the other is that when a bad guy compromises your server, they'll try to open a reverse shell and send traffic to the command and control server from the server, and you shouldn't allow that. That's why exfiltrating data from a network during an attack is difficult. You can't just take a high-value server and go straight to the internet. You have to go through a circuitous path to get out. So I'm trying to find if any traffic went backwards on my network, where the server was a client instead of a server. Now, I don't see any events, but I have sampling turned on, so the first thing is to turn that off so I see all the events. And it's searching, and by the way, you can tell when it's done when you see a green check mark up here. So it's still filtering through the million events, and now it's done. It still finds 0. And that's because I left my domain name in here. Now, if somebody on the server opens a web page and goes somewhere, it's not going to have my domain name in it. It's going to have some other domain name wherever they're going to. So I need to take that out of the query. And now this is what should never happen. There should be no HTTP requests coming from my web server. If that happens, that's traffic going backwards through the network, and that should not be allowed by your router access control lists and firewalls. And it's been happening on this network, which is a clue that they're kind of sloppy on this network. There are 9 times the server has been a client. So here's one. Some big binary file has been downloaded with all this junk in it. It looks like an image with an EXIF in the header. All right, and that's one thing. Okay, and this looks pretty informative here. In fact, I can probably change this to a better view with this greater than sign. That will show it, break out the fields on the bottom. Here we are. So that is a request, and it went to this IP address starting with 23, and the request should have a URL. It's irritating me and not showing it to me clearly. I can see it up here, though. It sent a GET request to Poison Ivy is coming for you, Batman. Now, let me see if I can make that look prettier. Yeah, this is set on list. Yeah, list should be good. Don't know why that one is determined to show me the event in an ugly way. I think the next one lays out nicer. Yeah, here we are. Next one lays it out pretty. So it's going to this suspicious URL down here, a prankglassine.jumpingcrab.com, and on a suspicious port 1337 instead of port 80, and it's downloading an image with a suspicious name. So what happened is the bad guys gained execution on our web server, and they used that ability to launch a request from the web server that downloaded an image from a staging server where they've got objects to be used in attacks, and they put it on the server and defaced the web page. So now we know the domain name of their staging server, we know the name of the image they downloaded, and we know the IP address of their staging server, which is up here. And so if we want to know more about their attack, we can use open source intelligence on that IP address. So just go to Google and search that IP address of the server they downloaded that malicious image from. And you'll see the usual open source intelligence sources like Alien Vault and ThreatCrowd and ThreatMiner are here with information about that IP address. If it's been used in previous attacks, they'll have information about it here. It's an Amazon service, and here's the other domain names it's had: Wayne Corp Inc., PoisonIvy.com. That's a suspicious looking domain name where they've switched letters to numbers. Then that's leet speak. That's a likely an attacker group. If you go to ThreatCrowd, they say it has been voted as malicious, and it has another list of domain names, including the one that we saw, prankglassinebracket.jumpingcrab.com. So this same server has been used with several different domain names for attacks. And I think ThreatMiner didn't have anything much more to add to this for us. All right, so there are some facts about the server. So what we've learned more about this attack now. We have learned the IP address of the staging server, the domain address of the staging server, other domains it uses, but we have not yet figured out how the attacker gained the ability to execute code on the web server. By the way, if you scroll down and look at the earlier events, you can see what else has been happening on this server, and what's happening is Joomla updates. This server is downloading Joomla updates directly to the server, which is not a bad thing really, but it just shows poor sanitation. You should not be downloading updates directly to the server. They should be going somewhere else, scanned for malware, and pushed out to the server over the local network. All right. And this is, like I say, this is why people pay so much money for Splunk. It was very easy to find the 8 events out of 1,000,000 that went backwards and pick malicious events out of that pile of innocent traffic. And that's why it's so nice to have this efficient search engine. You could do this with simpler tools, but it would be harder to get the job done.